welcome back once again. Today we have a very interesting equation. Yes, this is a Math Olympiad problem. We're given the following equation whose base is a linear equation with a quadratic exponent. And this base raised to the power of this quadratic exponent or quadratic expression is equal to 1. The question here is, can you solve for all real values of x? I know you might be wondering, how can we solve this problem? If you have this idea that anything raised to the power of 0 is 1 except 0 to the power of 0, we can write the right hand side as 6 minus x raised to the power of 0 so that you can compare the both sides and equate the exponents since we have obtained the same basis, right? If you equate the exponents, so we get x squared plus 7x plus 12 is equal to 0, of which you know that x is equal to negative 3 or negative 4 from here. But the question here is, are there more solutions? If you do this, yes, of course, these are solutions. Both negative 3 and negative 4 satisfy the equation. The question which I asked earlier, are there more solutions, is a very nice question. Yes, indeed, there are more solutions. Then, how can we get the other solutions? So let's see how we can solve this problem. So in this video, I will show you guys how many cases to be considered here. Okay, so we're going to start with the first case, and it will be well explained. So if you do this, which I just showed you now, you will just get the solution 50% correct. So let's start. Now we're going to consider the first case. Let's call it case 1. So for the case 1, we're going to consider the following. And what is that? What we're going to consider here is that 1 raised to the power of n will always give us 1. So this is really very nice, right? Whether n is both positive or negative. I mean, whether n is positive or negative, this will always give us 1, right? For example, when we have 1 raised to the power of 8, this is also 1. If you have 1 raised to the power of negative 8, it is also 1, right? So you can see this is a very nice case. So that is our case 1. Then how can we use it to solve the problem? We're going to use it to solve the problem. We know that in that case there, the base here is 1. So in the problem, the original problem, we're going to let this base equals 1 and find the value of x. So that will be 6 minus x is equal to 1. So if you solve for x, we get x is equal to 6 minus 1, which is equal to 5. So this is a solution. Is that not interesting? Check it out. That must be a solution, right? So let's go to the second case. So for my second case now, let's call it case 2. So we're going to consider the following, that negative 1 to the power of k, or you use n or use b, whatever. So any letter you wish, you can use. So I'm using k. So negative 1 to the power of k is equal to 1, but there must be a condition. If and only if k is even, right? Cool. So k must be even for this to hold, right? So again, let the base 6 minus x equals negative 1. We get x is equal to 6 minus minus x, 6 minus minus 1, which is 6 plus 1, which will give us 7. Again, we come up with another solution that x is equal to 7. Now consider the exponent x squared plus 7x plus 12. Plug in 7 for x. So we get 7 squared plus 7 times 7 plus 12. Here we get 49 plus here we get 49 plus here we have 12, right? So 49 plus 49 will give us 98. Did I get it right? Yes. So we get 98 plus 12, of which we know that even plus even will give us even. So therefore this sum, whatever it will give us, must be even. You can see that the power will be even and the base will be negative 1. So 7 is the solution, right? Then our final case, which is our case 3, is where we have the following. we're going to let the exponent equal 0. For example, we have that x raised to the power of, what should we use? Let's say x raised to the power of m is equal to 1. So here m will be equal to 0, right? And again, we know x cannot be equal to 0. So this is the case we're going to consider as our last case. So for that, we're going to let the exponent x squared plus 7x plus 12 equals 0. So here we're going to use the factorization method to solve this problem, okay? So let's find the product of this leading term and the last term. So that is 12x squared. So this stands for product. Then this one here is positive 7x. So this one here stands for sum. So we're going to look for two terms that their product will give us 12x squared and their sum will give us 7x. So these two terms are 4x and 3x, right? If you say negative 4x and negative 3x, you will find out that their product will still give a positive 12x squared, but their sum will not be positive 7x. So these are the only two terms to be considered here. So we're going to rewrite the second term here, 7x, as the sum of 4x and 3x. So like this, we get x squared plus, so this will be 4x plus 3x. And here we have plus 12, so this is equal to 0. Factorize, we're going to factor out x here, right? Factor out 3 here. X into brackets x plus 4 from here, plus 3 into brackets x plus 4, so this is equal to 0. So from here, we have x plus 4 multiplied by x plus 3, and this is equal to 0. So if you let this one here equal 0, and let this one here equal 0, you'll find out that x is equal to negative 4, and from this side, x is equal to negative 3. So you can see we have 4 solutions, right? So we have the following solutions to this equation: 6 minus x to the power of x squared plus 7x plus 12 is equal to 1. So we have that x is equal to 5, x is equal to 7, x is equal to negative 4, x is equal to negative 3. So these are the only real solutions that satisfy this equation. Did you enjoy the video? Kindly subscribe. Also like, comment, and share.